There's been a recent scramble amongst tech providers and logistics companies to create an automated delivery system that will reach mass adoption. The drone trials may look impressive, but it hasn't always been clear skies in the testing. Dropped packages and sticking the landing has proved to be quite a challenge. Similarly, with autonomous delivery robots, the tech is there, but there may be one challenge that's overlooked: human intervention. The sight of these delivery droids on their sides with wheels spinning, or watching them become the victims of attempted theft, has blighted several of the trials. It isn't exactly the rise of the robots just yet. Perhaps that's why underground ideas are proving to be a better foundation. We are now seeing a host of companies developing automated micro-trains, conveyor systems, and distribution networks, all underground in order to get packages to people as quickly and efficiently as possible. However, creating an infrastructure of underground tubes sounds like a logistical nightmare. So why are companies attempting this? How is it being implemented? And who benefits from this new technology? Questions on the climate, sustainability, resource efficiency, and how to serve ever-growing and aging populations are now pressing matters for innovators and engineering communities all over the world. And, as you may expect, this is a particularly hot topic in the worlds of logistics and deliveries. Our global reliance on the road networks as the most important part of domestic cargo and freight journeys is astounding. Data shows that a staggering 72% of the total tonnage of goods transported domestically in the United States is via road. That's a hell of a lot of delivery trucks, vans, cars, and motorbikes clogging up the highways. If you also consider that 24% of global greenhouse gas emissions currently come from traffic, that puts us all in quite a harmful jam. It's not just the fumes that are causing government administrations to choke either. The implications of this much congestion on our roads every day has huge financial costs too. In 2018, this amounted to an estimated loss of $87 billion in the United States alone. That amounts to a $1,377 loss for every single driver on the road that year, through lost productivity, wasted fuel, and increased travel times. For highly congested regions around the world, this means an economic burden equivalent to 1% of their GDP. So it's easy to see why we are now looking for a road freight U-turn. Easing just a fraction of this traffic congestion would bring benefits environmentally, economically, and would also begin to shape how we plan our cities, our lifestyles, and our entire future in a positive way. So how did we get to such a bad position so quickly? The revolutionary benefits of a hyper-connected world in the last 25 years, driven by the rise of the internet, has meant that ordering goods became a far simpler and faster process, which ultimately means that people now order more, with millions of businesses built on this convenient reliance. All those clicks amount to wheels on the road somewhere along the line. However, the infrastructure currently used to support this new world of commerce is the product of a different time, and it's showing some clear signs that it won't be able to cope much longer. One of the most interesting areas of development currently being researched and tested is the use of underground conveyors and cargo robots. Through projects on huge scales of world-changing potential, with promises of incredible benefits attached. The foundation of the technology is nothing new, of course. Going underground is a philosophy that has fascinated engineers, scientists, and inventors for hundreds of years. There are entire worlds of engineering at play below our feet right now, providing energy sources, sanitation, and even connecting countries divided by seas, with the Eurotunnel sitting 75 meters below sea level, transporting over 1 million trucks and around 2 million passenger vehicles every year between England and France. On a smaller scale, we are familiar with systems like the pneumatic vacuum tubes, commonly used in large stores and supermarkets as a secure way to send money throughout the building. This technology was invented as far back as 1799 by William Murdoch and popularized throughout the 1800s. Some of the most impressive examples of this technology include the Prague Pneumatic Post, which is the world's last preserved municipal pneumatic post system, totaling about 55 kilometers of underground tubing. The system started operating in 1889 until it was rendered inoperative during the August 2002 European floods. Current restoration plans are in effect, however. Older projects, such as the famous Chicago Tunnel Company, also point to a rich history of subterranean success. Connecting over 60 miles of narrow-gauge railway underground, this network was revolutionary at the time. Initially, it was created to support a new telephone system for the city, but eventually it became a vital contribution to Chicago's development as a thriving metropolis, with the tunnels used for freight purposes, transporting goods directly to and from rail yards and other distribution centers, right into the heart of a growing commercial hub. The benefits were clear to see. It was protected from all the elements at all times and didn't have to consider the movement of the city's residents or non-commercial cargo. It wasn't long before the world began to notice. In the UK, Royal Mail followed suit with their own tunnels that became known as Mail Rail, from Paddington in the west all the way under central London to Whitechapel in the east. Underground electric trains ran on 2-foot-wide tracks, with a purpose-built and private network, connecting post office sorting centres to railway stations to transport letters and parcels. It significantly speeded up the mail process for the city and alleviated much of the congestion on the early 20th century streets above, running for almost 76 years from 1927 to 2003. And even before these two modern-age marvels shuttled beneath the streets, leather belts and labor-intensive hand-driven pulleys were the backbone of industrialized processes that carried coal and ore in mining operations during the boom of the 18th century. As the age of the motor car began, these innovative tunnel solutions were buried in favor of 4 wheels, and roads upon roads were laid across the planet, informing the structures of cities and transforming our ways of life. But now we're looking down again. Even famous tech figures that have spent the last decade looking up to the stars, such as Elon Musk with his investment in SpaceX, funding journeys away from the planet, we are now looking beyond the ground beneath their feet, with his Boring Company promising to put underground spaces to work for freight and utility applications. Companies like the UK-based start-up Magway are combining the traditional idea of underground conveyor systems with some pioneering technology too. That could produce networks on a bigger scale that we have previously seen. Magway's linear magnetic motors produce controllable and efficient motion, powered directly by the grid, with no need for batteries. The cargo is ferried in pods with a collection of specially arranged magnets on the chassis. This collection creates a magnetic field for the motors to interact with and propel the pods along the bespoke modular designed tracks. The body of the pod is determined by the cargo it carries, with special designs for bulk materials, parcels, groceries, and medicine. All of this takes place in 1-meter diameter pipes that will run between distribution centers and can even be applied to existing infrastructure. To reduce initial costs, Magway will run at 50 miles per hour, with a carriage capacity of 250 kilos and 1,200 carriages per minute available on the line. Importantly, it carries a zero-emission claim that could make it a potent force in this space. A recent showcase at Wincanton's W2 Innovation Centre in England was the first time it was tested outside of their own facility. with impressive results noted. The Transport and Tourism Ministry of Japan is making its own plans for a project that will certainly have keen engineering eyes on it. It has proposed a massive 310-mile, fully automated underground transportation system that will carry goods from Tokyo to Osaka and back. Interestingly, although the claims to ease congestion and benefit the environment are well recognized on similar projects around the world, it is the response to the challenges of an aging population in Japan that make this project stand out. Official figures show that the country lost around 837,000 people in 2003. This represents the biggest annual loss since records began in 1950. It also demonstrates a sharp decline for the working-age population, from a peak of 87 million in 1993 to 75 million in 2018. Prime Minister of Japan, Fumio Kishida, has recently stated that the country is on the verge of not being able to maintain social functions. According to the ministry's latest projections, without workers available to fulfill the jobs required for logistics and delivery, 30% of the packages shipped in 2030 would not be able to be delivered. If it does go ahead, this incredible $26 billion undertaking is ambitiously penciled in to be completed by 2034. In Switzerland, plans for an underground conveyor revolution are taking the first steps towards realization and rollout. The Cargo Sous Terrain project began drilling tests in 2023 for the first 70-kilometer section that will connect Herkingen to Zurich. This is planned to begin operations as soon as 2031, with automated driverless transport vehicles picking up and depositing loads automatically from ramps and lifts that join the surface distribution centers to the network of 6-meter diameter underground tunnels divided into 3 lanes that will run 24 hours a day. By adopting existing infrastructure for its destination stops, Cargo Sous Terrain will have links to the important last mile of delivery infrastructure that delivers to people's homes, alongside the air, rail and sea connections required for import and export. Eventually, CST has plans to connect the cities of Geneva, Basel, Lucerne and St. Gallen with around 500 kilometers of tunnels that will reduce heavy goods traffic in the country by around 40% and considerably affect CO2 emissions and noise pollution in a positive way. Although Cargo Sous Terrain has progressed through planning, it is now in the preparation phase. The world will be watching to see the results in action over the next decade. These projects very quickly ascend into tens of billions of dollars. CST is estimated at a cost of £35 billion to complete in 2045. But with any unseen challenges or obstacles adding to the bill, and so much of the technology untested and unproven at the scales required, digging for gold in this industry is going to be a difficult task, carried out in unknown territory. And there are some quite expensive skeletons already buried here too. The multi-million-dollar planning involved for Virgin Hyperloop and Elon Musk's own Hyperloop project that were similarly positioned at certain points as freight infrastructure alternatives with elements of the same technology have both suffered from semi-abandonment, leaving very expensive bones behind. The advantages of a new underground freight infrastructure would undoubtedly herald positive changes. Less traffic on the roads lends a serious hand to environmental targets for the whole planet. Less commute times means satellite towns further from city centers and recognized hubs will be allowed to flourish and develop. And human-centered design for built environments will be simpler to achieve with a great load of the logistics requirement removed, meaning green spaces may be reclaimed and new housing could be created in repurposed infrastructure. However, with so many challenges waiting to be uncovered, keeping your ear to the ground on these projects to listen for any dangerous rumbling underneath is always highly recommended.
Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching and see you in the next one.